Hi students. The purpose of this short video is just to look at the relationship between Ka, the acidity constant, and the hydrogen ion concentration, and we're going to look specifically at weak acids. So one of the questions in the worksheet asked you to find the hydrogen ion concentration of a 0.153 mole per litre hypochlorous acid solution, and it's given us a Ka of 3.2 times 10 to the negative 8. So if we draw out the equilibrium constant or the acidity constant expression for this particular acid ionization, the products of the reaction are the hypochlorite ion and the hydronium ion. Just check that I got that the name of that anion correct. And that'll be over the concentration of the reactants, the hypochlorous acid molecule. If we look at our concentration ice table, then we know a few things. So to start off with, the initial concentration of the acid, hypochlorous acid, is 0.153, and we know that we generally, at the beginning of the reaction, have no products to start off with. Now the change in acid molecule concentration, since we're not given percentage ionization, or we're not given any concentration of reactants or products, that's what we're trying to find, we can say that the change is going to be minus x. And so if we say that the value, we give the expression x, okay, since it's a 1-to-1 ratio, whatever concentration of acid molecule ionized, that will be the same concentration of hydrogen ions produced and the same concentration of hypochlorite ion produced as well. So our ice table looks something like that. At equilibrium, the concentration of acid molecule is 0.153 minus x. Hydrogen ion concentration, hypochlorite concentration are the same, both measuring at x. So what does this look like in terms of the equilibrium expression? So if we plug in 3.2 times 10 to the negative 8 is equal to x times x over 0.153 minus x. Now, this looks a little bit foreboding, okay? And if we were to take into account the negative x on the denominator, this would become what we call a quadratic equation. And that is a little bit complex for the purpose of our studies of chemistry. So we're going to use a little trick here, okay, which some of you have already figured out. And it's that this minus x value represents the concentration of acid that has become ionized. Now we know that for a weak acid, this is pretty small, okay? The percentage ionization of weak acids is pretty low. So we're going to say that the concentration of acid that has become ionized is so small so that negative x is we're just going to discount it altogether. We're going to say it's negligible in comparison to the original concentration. So we're not going to get an exact value for x because of this, so it's an approximate value. But this is just going to make it easier for us to do our calculations. So therefore, 0.153 minus x is equal to approximately 0.153. So that makes it a little bit easier for us to work out the value of x, which is then going to be the square root of the Ka value times the original concentration of the hypochlorous acid concentration. And that gives us a value for x of 7 times 10 to the negative 5 moles per litre. So we know for x, positive x was both hydrogen ion concentration as well as the hypochlorite ion concentration, which is equal to 7 times 10 to the negative 5. So this is how we're going to, well, this is the method that we're going to use to answer these questions that we looked at today in class. And we know from hydrogen ion concentration that we can work out pH, we can work out pOH, so we can do a series of things once we've worked out hydrogen ion concentration in the solution of a weak acid. Okay, I hope that helped, and that was nice and short and sweet. Thanks for watching.